on one end. The green signs on both ends of a cable, it means there's connectivity established between the switch and then the end device. We good? So after you connect the cables, okay, what is the next thing that you're supposed to do to have the device actually communicate among themselves? How do you get all the device to actually talk to themselves? Okay, what do you have to do? What's the next step in order to get this device to actually talk to themselves? What do you have to do?
So you assign them IP address.
There you go. We assign them IP address because IP address are needed for these devices to be able to identify themselves and be able to identify others within a given network that they find themselves in, and also be able to exchange information back and forth. It's kind of like, you know, having phone numbers. You know, if you want to talk to your girlfriend or your boyfriend or whatever, you need their numbers, right? Let's say you meet a girl at a bar or at a club or at the mall or at a shop, or whatever, and you want to basically, you know, keep, you know, conversation with that person or that girl or that boy, or whatever it is. You want to, what do you do first? You ask for your number, right? Can I get your number so we can talk more? You know, the same thing. Yeah, so we have, in this case, we have to assign IP addresses to the devices, okay? Now, there are two ways that devices can be assigned IP addresses. There are two ways network devices can be assigned IP addresses. One of them is dynamically, and then the other one is statically. Dynamically usually goes with a system or a server, okay, called the DHCP server, okay, or the host, sorry, the dynamic host configuration server. That's the one that handles most of the IP lease or IP, what you call it, IP allocations within a given network automatically. Okay, so whenever you're connected to a network and then there's a DHCP server on a network, it would help you acquire an IP address for a given period. For the most part, IP addresses are leased for either something like during a day, for a day or for a week. It all depends on how you configure the DHCP server. When I went to college, we were leased IP address for the whole semester. So the IP address you got at the beginning of the semester is what you basically carry through the entire semester. So when you do have that fixed IP address allocated to you, you know, via DHCP system for the entire semester, it means that anything that you do, they can easily trace you, you know, because they know that's your address. If you were to be watching porn on a university network, you get a query, you know, hey, dude, we gave you an IP address and we gave you some rules or disclaimers and you're not complying by them. You're gonna lose your privilege if you keep watching porn on a university network. You know what I'm saying? So that was a good way to basically handle some of these issues that relates to curious and crazy students on campus. So you will lease an IP address for the one IP address for the entire semester, okay? And if you have multiple devices, they also get their own IP address, but they're all linked to your name, to your account, to your index number, or to your profile as a student of the university.
Yeah.
Pretty exciting stuff.
Yeah.
Yeah. Great. So those are two main ways you can allocate IP addresses on a given network. Okay. You can either allocate it dynamically via DHCP server, or you can allocate it statically in a manual fashion, where you basically go into the network settings, go into your IP configurations, and search for IP version 4, version 6, and then manually key in the IP address that you want to do. Okay. Okay. Now, on the other hand, let me point out something too. When it comes to key network devices, regardless of whether you have a DHCP server on your network or not, key network devices must always be statically assigned an IP address, or must always be statically allocated an IP address. So key devices like a router, a switch, a server, an access point, those are key network devices that play specific role. They play fixed specific roles. So they must be assigned static IP address. That doesn't change. The printers as well, exactly. That do not change on a regular basis. Are we good? So at least anybody can reach them at any given point in time, anytime they want.
I think IP as well. IP phones as well.
IP phones, yeah, there are a whole bunch of them. Yeah, there you go. So anyways, yeah, so those key network devices must always be assigned static IP address. Are we good? Great. But PCs, laptop, your smartphones, or whatever, those can be assigned IP address dynamically. Okay, so it can be leased for a week or for a day. It all depends on how you set up your DHCP server services and its allocation time and its lease time. Okay. So for now, we're gonna go through a static assignment process, and then later on we're gonna configure your DHCP server on our system over here, now server over here, so it can handle dynamic IP allocation. Okay. So to do that, just click on this PC over here, or let's start with the server. So click on the server, and you should see the front view of the server with the network ports, blah, 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 you know, various interfaces and modules that you can interact with. Are we good? Now click on desktop. So on the window that pops up, it has physical, it has the physical view of the server, it has a configuration view, it has the services, it has the desktop, programming, and attributes. I go to desktop and then click on IP configuration.
Hello, sir.
Yes.
Please, if you are going to sign a dynamic DHCP with the server, then we should assign IP addresses to the laptops, or
I'm saying that we're gonna go through statically first, and then later on once
okay.
At least users can know the static way of assigning IP address before we configure the DHCP server.
Okay, sir. Thank you.
Okay, so now
please allow the man to do all. This is for us, not for you.
So if you click on the IP configure, you see the two ways of assigning IP address to network devices, either via a DHCP system, which is dynamically, or statically manually. Okay, so we're going to start with a static assignment first, since we only have about 5 or 6 machines over here. Okay, let me point this one out. Within a corporate environment where you have and maybe you have a lot of devices, it's ideal, say about 200, 300 computers. Always try to set up a DHCP server to handle the IP leases and allocations. Okay, because trying to go through 100 or 200 end devices or PCs or laptops with static assignment, it's quite tedious. So you don't want to do that, okay? So please, when you have larger numbers of devices, that needs to be always set up your DHCP server to handle that workload for you. But if you just have a small lab, a small lab of say 5 PCs or 6 devices, and you can just go with the static assignment and just reserve that DHCP for a later date, okay? Okay, so we are looking at the finance side, and we've already indicated we want to use this network address, okay? Or yes, network address. So we're gonna start with the server with the 192.168. Actually, before that, let me label the IP address for the devices. My server is gonna be 168.1.10/24. And then PC1, 192.168.1.101. I'm using 101. I want to preserve or reserve from 1 to 100.
Hello, sir. Hello,
As a
sir.
reservation, yes.
Hello, sir.
Yes.
Please, you see, when you were coming out with the IP address, my network was having some issues, so I didn't know how you came about that IP address. So
Oh no, I just said I want to use this IP address, a Class C private IP address for the entire network, but I'm going to separate them into 2 separate networks. One, I'm going to use a 192 for the finance department. I'm going to use a 192.168.1.0/24, and then for HR department, I'm going to use a 192. So this is a decision you have to make. You have to make a decision. I could have chosen to go with a Class B private IP address or public IP address, but I just want to use a Class C because it's a simple lab setup. Okay, so you have to make that decision yourself. Are we good?
okay, sir. Sir, I'm good. I'm good.
Okay. So PC1, PC0 has got the 101, and I'm going to make this one over here. Okay. This one over here will be 192.168.102/24. Okay. And this will go here. And then you can do the rest. So 102, 103, 104, 105. Okay. You open them up so we can assign them evenly. So all devices can have their, can be separated a bit more. Okay, go ahead and add them. So this will be maybe 103, 104, 105. Are we good? So just use your note. 192.168.103/24, so forth and so forth. Okay, so go ahead and do that. Great. So now let me actually start applying them to the devices. So you go to desktop, IP configuration. So 192.168.1. This is PC0, right? Yes, PC. So that's 101. And when you click the subnet, it should automatically show the default subnet for Class C IP address. Okay. We're gonna leave the gateway and DNS later for later configuration. Once you're done, you click, you exit that. The server, the same process, 192.168.1.10/24. PC1, same process, 192.168.1.102/24. 103, 192.168.1.103/24.
Hello. Hello.
Yeah.
Yeah.
Master, official, meaning no. Let and Tony official. 192.168.1.104, right? Yes, 104/24. Who's got a question? Prince. Do you have a question, Prince?
Sir, it was earlier on question that I wanted to ask.
Okay.
static address. So the
Okay.
devices that I use for a static address is what I wanted to ask.
Okay.
You mentioned about access point, server, then the rest I did not get it, so I wanted to ask.
Okay, there are printers, there are IP phones, servers, routers, switches. Key network devices must always be
Dedicated
assigned.
devices.
Yeah, the key network devices must always be assigned static IP address, irrespective of whether you have a DHCP running or not on your network.
Okay, sir. Thank you.
All right. Okay, so as it is now, we have IP address for all of our devices. Okay, so let's focus on this side first before we move on to this side. Okay, so now that you have IP address on all of the PCs and servers over here, how do you troubleshoot to see if they can actually talk to each other? A good way to figure that one out is by using a popular network command called the ping command. The ping. So
the ICMD.
The ping command, yeah, the echo command. So use a ping command is one of the most important or widely used command to basically determine if a device on a network is alive or dead or is connected or not. Okay, so if you want to figure out if a device can actually communicate with other devices or can access another device, you use the ping command. Okay, so ping is used to check if a device on a network is online or not, is dead or not, or is connected or not. So for instance, if I wanted to basically check if Facebook is online or not, I can just say ping Facebook. And when I get a response, it does the resolution to the Facebook's IP address. Okay. Now, if you notice, I'm getting a request timeout over here on my device. Even though I'm online, that's because I have disabled ping on my network to avoid broadcasting of all kinds of unnecessary stuff from outside. If somebody wants to hack into my system using maybe a denial of service command or whatever, because of that disabled ping on my network. But if I can still access the internet anyways. So that's why I don't have Facebook not going through. Yep. So once you type ping and then a domain name that you're trying to reach or the IP address, so I can use ping instead of typing a Facebook, I can just type the IP address. In this case, it's 157.240.212.35. That's Facebook service IP address. So I'm going to respond back because I've disabled the ping echo command on my network. Okay, so there are no echoes back and forth for denial of service issues on my network. So I can block some of those things. That's why it's not going through. Okay, but I just want to basically let you know that the ping command is what you use to tell if a device is online or not. Okay, and usually when you do a ping, if the device that particular device or network that you're trying to reach has their ping enabled, then you're supposed to get a summary information that states that 4 packets were sent. Usually what ping does is it sends packets to a given device that it's trying to reach. Usually about 4 packets that is sent. And it's expecting that when that 4 packets hits that particular device, that device will respond back with the exact number of packets that were sent. If it gets anything less than the 4 packets that is sent, it could mean that there's a problem with that particular device or there's an issue on the connection towards that particular device. So in this case, we got sent 4 packets, received 0. So we have 4 losses. So it means that connection did not go through at all. But like I said, the reason why it's not going through is because I've disabled ping on my network.
Okay.
Yeah, someone is asking if network topology is considered over here. Yes, over here we're using a star topology, right? This is a star topology that we have over here. We have a centralized node that every other device connects to. So as far as
so
as far as what you call it,
Gabby,
oh,
please
does
mute
it mean
yourself.
okay, Mate? What am I? Hey, me near me.
so as far as what you call it, the topology is concerned, we are using a star topology way because we have a central node that interconnects all the other end devices. Okay, so we're going to try to use a ping to see if you can reach maybe the server from this PC. So click on the PC, and then you want to use the command prompt. So on your Windows CMD, right? That black screen you get. So this way you do your DOS commands, settings, or whatever, you know what I'm saying? So the CMD is also over here. Click on it, and then let's do a ping. So since we don't have domain name resolution on our network right now, we're going to go by IP addresses. Okay, we don't have a DNS here to handle name resolution, so we're going to go with IP address. So the device we're trying to reach here from PC0 is the server, and the server is going to an IP address 192. So ping 192.168.1.10. Hit enter, and you should see this reply. And this is what you want to see. Ping sends 4 packets, and the device, so this PC0 here sent 4 packets to this server over here. And the server replied back with 4 packets. So meaning that it received and acknowledged that it received 4 packets. So indicating that there are 0 losses, or there are 0 losses, we have percentage loss is 0. And it gives you a round trip of what? 30 milliseconds, an average of 7 milliseconds. Usually when you get higher milliseconds within a simple LAN implementation like this, it means that there's an issue somewhere. So try again, try to ping again, see. You're supposed to be getting more or less than 1 millisecond. Your statistics. Your stats should be at least, see that, an average of 0 milliseconds, what you need to be getting. You shouldn't be, for a simple network like this, you shouldn't be getting anything above 1 millisecond. If you do a ping after you set up your network and you ping a device on that simple network, and you tend to get an average round trip of anything more than 1 millisecond, it means it's a problem within your configuration or within your installation. Either you've not done something right, you've not configured something right, and now you need to go back and check on that. Okay? What you need to be getting within a simple network like this is 0 round trip and the average. Okay? Great, so we can reach the server comfortably without any issues. Let's see if we can reach the other PCs. So I'm on PC 0, right? Let me see if I can reach 102. 102 is the next PC over here, right? I can reach it as well. See? Round trip average is 0 milliseconds. That's good. It means you've done a good job. Your configurations, your setup is top notch. Are we good? Now, if you want to check the kind of IP address you have on your network, your network interface and its IP address, there's another command called the IP config. So ping an address or domain name, an address / domain name. So domain name are your facebook.com, google.com, blah, blah, blah. And your IP address are your 4 octets, okay, revolve within class A to class C. Oh. So the next command that you want to be playing around with as a network engineer. So by the way, if you're going to be from today onwards, let this ping command be on your fingertip. if you're having connectivity issues on your network, whether irrespective of whether you are a network engineer or one of the key network administrators or not, try to use some of these key ping command to troubleshoot what's going on. So assuming that there's a system within the organization that you access on a daily basis, and one day you came in and you couldn't access it, what you can do is just ping the device. Okay, you just open the DOS prompt and type ping the device. If you have the IP address, if you know the IP address, ping it. If it has a domain name, ping a domain name, see if it's responding. And then you can basically figure out what the problem is or where it's coming from. Okay. Somebody is saying, say, you asked us to install VMware as well. Yes, that will be later. That will be for your actual system designs, where you're going to build servers and blah, blah, blah. So we're not there yet. So Hamza Maxwell, just hold your horse, okay? We'll get there. This is just a basic network setup first, okay? Great, so the other command is ipconfig. That's where you use basically the IP configurations within your device that you have. ipconfig for short, or IP configuration, okay? So this helps you figure out the kind of IP, so the network interface that you have and the IPs that are on it. So let's type that, ipconfig, and you see it tells you the interface that you have and the IP address allocated to it. So and within this, we have a fast Ethernet by default port, and then we also do have a Bluetooth connection, which obviously is not been assigned an IP address. But the fast Ethernet port has been assigned an IP address statically with a 192.168.1.101. Okay, so yeah, so that's one of the commands that you need to basically keep in mind of. So ping and ipconfig. Now ipconfig also comes with our parameters to basically narrow down a given specific interface or setting you're looking for within the IP configuration. You can use /all. So if you do that, it tells you the entire physical interface of the IP system and its IP configuration. So ipconfig /all, and that tells you all the physical interfaces and their configurations. Okay. Yes, if you're using Apple devices, it's ifconfig because you're using the Linux, sorry, what's the command? The Unix operating system. Your Unix operating system. So you have to go with their command. Windows uses ipconfig. Unix-based system uses ifconfig. The if is actually interface, because with Linux-based system, they reference their interface, their port interfaces with the if. Basically the word that has been shortened to if. So if stands for the interface configuration. Okay, so you use a terminal and then you type ifconfig. For those that use Windows prefer to use the its own terminologies or its own command base, and it prefers to use the IP instead of using the if for Linux. Okay, so it's Linux is a Unix-based device system, operating system. Okay, so Unix, Linux, Linux and Ubuntu, depending on the flavor that you have, either Ubuntu, either Debian, either Fedora, either OpenSUSE, Open CentOS, and what have you. Those are all the flavors that we have. Kubernetes or whatever. So all of these are just flavors under Linux, but they all come under Unix-based architectures. Okay. So yeah, so they all follow Linux. All their commands follow Unix commands.